Hello, Accelerated class. We are approaching the end of the school year, and I wanted to make a quick video today about the 5 assignments that I am assigning for the week. It is 5 lessons on Delta Math that require you to look at transformations. So I'm going to do an example from each one of these lessons so that you can see how to do this if you're having difficulty. And you can do these all in one week if you want to. I'm doing one per day. Please watch this whole video before you email me because it is a little tricky, and that's why I'm making the video today. So the first one that you're going to do that's assigned is transformations, and we did something in the middle of the year. We mostly transformed lines, but I believe I made your class transform shapes. So for instance, this one says translate the figure 2 units left and 2 units down. So that means every vertex here needs to go 2 units to the left and 2 units down. So I'm going to go 1, 2 to the left, 1, 2 down, and that's my first point. See, I don't need this one up here. So if you want to undo a point, I believe you can unclick it. Maybe not. All right, whatever. We're going to try the next one. So this one, if I go 2 units to the left, 2 units down, here's my next one. I believe I should be able to drag this one. Oh, okay. Just clicking it undoes it. So this is what I mean. It might be a little tedious to some of you. You will unclick the points just by clicking it. So this last point, I need to go 2 units to the left and 2 units down. And as you can see, the shape still remained the same. So you're going to hit submit the answer. Are you sure you want to submit? Yes. And this is what I like about Delta Math. It actually shows the movement. So remember, a translation is a slide. We did review this in the beginning of the year, but I do want you to finish this lesson. The next one that I want you to do is find the line of reflection experimentally. So it says determine the line of reflection that would map the pink figure onto the dotted outline of the image under the reflection. So click and drag the yellow dots to change this line. So what you want to do first is you're trying to get that pink image, and you're going to try to get it into the place of where this dotted line is. So first you want to make sure that it is oriented the right way. So just play around with it. So this looks about good. It might not be. And then you're going to drag the line to bring where it needs to go. So obviously I did not do this correctly. So I'm going to keep rotating my shape until it looks about right. And what we're doing here is we are creating the line that the line of symmetry that makes this a reflection. So once you think you have it, you're going to hit submit the answer. Are you sure you want to submit? And once again, Delta Math is going to show you the actual reflection. And just like that, it's showing you how it's flipping over this line of symmetry, okay, or the line of reflection. So I think these activities are kind of easy. I think they're a little bit of fun, but they are important for you to understand what all of the transformations are. So this next one that you're going to do is you're going to reflect the figure over the line that's given to you. So y equals -1 is this blue line that they give you. It says pick all of the points of the reflected figure. You may click a plotted point to delete it. All right, so that's important to know. So what I'm going to try and do here is if I'm trying to reflect this image over this blue line, you're going to count the distance it is from that line. So this point is 1 away from the blue line. Therefore, on the other side, I'm going to go 1 away. This one is 6 units away from, I'm sorry, 1, 2, 3, 4, 5 units away. It's at -6. So here I'm going to go 1, 2, 3, 4, 5 away. This point is 1, 2, 3 points away from the blue line. So I'm going to go 1, 2, 3 points away from the opposite blue line. This fourth point is just 1 away. So I'm just going to go 1 point away. Now, you're going to be able to eyeball this. Does it look like a complete reflection? Right now it does to me, but if you maybe put a point in the wrong spot, it will show you. So submit your answer. It says, yes, I got it right, and it's going to show you the flip. All right. The fourth one is probably the trickiest one, and this is the one that we have not practiced. So I'm going to show you how to do this. Be patient with it. So it says follow the guided instructions below to rotate the figure 90 degrees clockwise about the origin. So if this is yellow dot is the origin, when I go clockwise, it means it goes to the right into the quadrant next to it, or here, but right now it's 90 degrees. So every time you go 90 degrees, it goes to a new quadrant. This would be 90. This would be if I went clockwise 180. This would be if I went clockwise 270. And if I did a whole 360, I would wind up in the same place. So just be aware of the direction that they give you, because sometimes they say counterclockwise, which is to the left. All right. So in order to do this one, it says draw a circle centered at the center of the rotation such that one of the vertices of this figure is on the circle. So vertices is the plural of vertex, meaning one of these points. All right. I've been calling it points. I really should have been calling it a vertex. So if I take my yellow line, it's going to draw a circle, and I want it to hit one of these vertices. So I'm going to make it hit this one. You could choose whatever one you want. You can make it go to this one or this one. Then it says click and drag to draw a line through the yellow center and the vertex. So here's my yellow center, here's my vertex, and I have my line. Now draw a line through the yellow center that is perpendicular to the line that you drew. Okay, so I need a line that's perpendicular going through the line I just made that has to be 90 degrees. So you guys really have to think back on when we were creating perpendicular lines with slope. So I'm going to go through this really quickly here. This slope of the line that I just made right now is negative, right? It goes down and to the right. So if I wanted to figure out what the slope is from this point to the yellow point, I'm going to go down 1 over 1, 2, 3. So that would mean my slope is negative 1 over 3. So what's the opposite? Up 3 over 1. So if I start a point that goes to up 3 over 1, I have a perfectly made perpendicular axis. Now watch what, not axis, I have a perpendicular set of lines. So watch what happens. You must answer all questions to submit. So now, even though I have this, now is when I have to rotate the figure. So now if I'm going 90 degrees, I'm going to take my shape. You got to click on this dot, and it is going to bring it over here. Okay. So this is what's cool about Delta Math. Animate the rotation again, and it's going to show you, oh, I did it 90 degrees. There we go, clockwise. This is what you guys are going to try to figure out the pattern of while you do this. So the pre-image, meaning this pink one, had one dot or one vertex that was at negative 8, 2. So it's saying when it went from negative 8, 2, where did this vertex wind up when we rotated it clockwise? Most of you will be able to eyeball it. It's this one. But if you can't, animate the rotation again, follow it, and this is our new point. So we're at 2, 8. So I'm going to type that in here, 2, 8. Okay. The point that was at negative 3, 1 when I rotate it wound up here, which is at 1, 3. You're going to notice there's a pattern going on with these numbers. The one that was at negative 1 up 4 is now at 4, 1. So as you go through this activity, you might find out this shortcut very quickly of what's happening with the coordinate points and their values. And this last one is negative 7, 5, and this one wound up at 5, 7. So as you go through, ask yourself, what happened to the y values when we went to the new image? What happened to the x values? All right. So once you have it, see if you got it right. Tells me I'm correct, and you'll go on to the next one. This one will probably take a little more time than the others, but I think this one is important because this is the one that we did not touch on a lot when we were in class. The last one is asking what transformations took place. All right, so after you do these 3 activities, you know that there's transformation, reflection, and rotation. Earlier in the year, we did dilation. I don't know if that pops up in here, but if you don't remember, dilation is either sizing an image up to scale or sizing it or shrinking it down to scale. So this one's asking, how did this point go from A to B? Well, it's still the same size, so I know it can't be dilation. I know that it's going from here to here. So you could either say it's going clockwise to this point, or it's going counterclockwise, all right? But you have to know the amount of degrees. So every time you go from one quadrant to another, that's 90. So if I say it's going clockwise, this would be 90, this would be 180. So look for a clockwise rotation of 180. I don't see that. I see counterclockwise. But ask yourself if that works. If I start here and I go counterclockwise, this would be 90 degrees, this would be 80. So right now I'm going to say it's this one. Look at your other options. Reflection over the line y equals x. There's no reflection going on. You could see that if you flipped it over, it wouldn't work. A counterclockwise rotation of about 90 would mean that the figure landed here, which is incorrect. And a reflection, once again, would not work. So as you go through with this, make sure you see all the options, and once you do it, it's going to show you the correct solution. All right. Please watch this entire video again if you need to as you go through the lessons for this week. Miss you guys. Bye.